In this video, we are going to do how many? 7 questions from the chapter probability, and that is based on tossing 2 coins, right? That's the one which is based on tossing two, not coins, sorry, 2 dice simultaneously. So let's begin with the first one here. I'll make space first. Let me delete the whole of it, and I'll type the first question here. So the first question is what? It says 2 dice are thrown simultaneously. Find the probability of getting a doublet. So for that, first of all, you have to make a table. I think you may be well versed of this, making a table over here. That means this is representing the first dice, and this one is representing the second one. Right? This being representing the second dice. So let's say, let me just tell you that if 1 and 1 comes, like in first dice 1 and second dice 1 is this. This is the observation when the first dice has 4 and the second has 3, like that. So I have taken this row as the first dice. Let's say this is the first dice and this is the second dice. This table you have to make in the examinations. And if you remember the observation, there is no marks for making the table. You may not do. So question is that here is 2 dice are thrown simultaneously. Find the probability of getting a doublet. So doublet is what? Like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. This is what called doublet. Now, if I talk about the probability, right? Probability is what? The number of favorable observation divided by total number of observation. While favorable observation you count, it is 6 here, right? That divided by total number of observation. So this is the total number of observation and they are 36. How did I get? I multiplied, right? This way it is 6 observation, right? There are 6 on this row and 6 in column. So that's why I said it is 36. So I'll say the answer is 6 over 36, which we may reduce and write 1 by 6. So this is how the first question is done. I'll type the next one here. What's that next one? Next is this. So what does it says? It says 2 different dices are thrown together. Find the probability that the numbers obtained in the first part is the even sum. Right? The sum is even, right? So let's do like this. 1 plus 1 is 2. It is even. But 2 plus 1 is not even. I'm going column wise. This is even. The sum is even, right? Similarly, 1 plus 2 is not even, but 2 plus 2 is even. 4 plus 2, 6 plus 2. If you keep on counting like this, right, you may end up getting the pattern over here, right? Pattern you can understand. But then it's a small question, so you may just circle those. I can figure out that there are half of them, right? So we don't write directly as half. We must write down the formula first. That is favorable observation divided by total observation and some statements, right? These marks for that. I'm doing it here directly. So you can figure out of 36, 18 of them is our favorable observation, and you can reduce this with 1 over 2. This second part also. Well, the product is even. This may not be as simple. We have to get the product as even. So to get a product as even, we have to see which of them is even. So 1 into 1 is 1, 2 into 1 is 2. So 3 into 1 is 3, 4 into 1 is even, 6 into 1. Similarly, 2 into 2, 3 into 6. Whenever any of them is even, right? The product of an even with even or odd with even. That's why you'll find more numbers over here. This also. Now, in case of odd, it's only 3 into 3, 6, 5 into 3, 15, 6 into 3, 18. So 4 into 3, 12, 3 into 2, 6. Many of them. 6. I did by mistake. This is not even, right? 3 into 3 is 9. 4 into 3, 12. I need to observe properly. This is 4 into 1. Yeah, this should be all of them because if one of them is even, all of them will be even. In the next case, I'll just look for even 4 into 5 and 6 into 5. The last one has to be all of them, right? As one of them is even, So the other partner may be product, sorry, odd, or even the result is even. So let me see. I have missed one more here. Are there more? I don't think. So I can see that the non-highlighted are this, right? I'll do like this instead of counting the whole of them. I'll say out of 36, out of 36, only 9 of them whose product is odd, isn't it? So therefore, 27. So the required probability, say I talk, say PB will be what? 27 over 36 on reducing by 9, 9 3 times and 9 4 times. So this is what we will get the answer for the second part. And that's the second in order, right? Let's remove it and we'll begin with the next question. Right. Now we are on third. Let me type the third one over here. Is that gone? Yeah. 1, 2, 3. And this is the third one. This is two different dice are thrown together. Find the probability that the sum such that the number have the sum less than 6. Well, in such a case, the number less than 6, mostly answers comes with diagonally. Less than 6. So I'll just go for 6, right? I just painted this one, right? This is 6. So let me show you what I mean to say that 6 is this, right? This mostly you have to, in case of sum, you have to observe diagonally, right? These elements will give the sum as 6, but we have to look for less than 6. So look diagonally, the triangle formed over here. This is 5, right? Okay. So there are how many of them? You just need to count these as. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers, right? 1, 2, 3, 4. You can see from here once again. These are the numbered. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of them. So answer for this part is going to be what? Say if I write PA, let's say PA for the first part. So it's how many of them? I lost the count. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it was 10. So 10 over 36. So it comes out to be what? 5 over 18. Let's write down PB and then we'll write PC also. Have a product less than 16. Product less than 16. So let's see which product will give you 16. 4 into 4 is 16. So what I'm going to do, I'll go for these numbers. These are big and their product, you can see that they cannot give you, right? These cannot give you. Product is 16. I thought something else. Let me once again do it. So product as 16. So this is how much? 36, 30, 30, 25. Yeah. 24, 18. Need to watch 16. This is 20, 20, 18, 12 is the right. 15, 16, 15, 16. I think others will be less than that. So this is 6, 10, 12, 12, 10, 6. So these must be the number, right? So these you can see that the leftover numbers, right, should be give you how much? These will be give you the product which is either 16 or less than 16. But then we have to say less than 16. Be careful. It's less than 16, so 16 should also not be included. So I have to erase this also. So rest are correct. So I just have to see that from 36, how many of them we have to cancel? This is 4, 5, 6, 7, 8, 9, 10, 11. So remove this 11, that is we are left with 25. So the required probability for the second case will be what? 25 over 36. Next, the third part, if I read, what is it? The third part is a doublet of odd numbers. It's not just a doublet. We have to get doublet of odd number. So it has to be 1, 1, ignore 2, 2, 3, 3, ignore 4, 4, 5, 5. That's easy to get this one. That is 3 out of 36 can be reduced 1 over 12. That's how we'll do the third question here. So out of 7, we have done 3 of them. Let's type the fourth one. So as 3, fourth is this. This one says 2 dice are rolled once. Find the probability of getting such numbers on the dice whose product is 12. Is product exactly at 12, right? It's not less than 12. So what we know that product to get 12 is what? 6 into 2. Where is 6 into 2? 12. And 2 into 6, right? So I'll paint it. So 2 into 6 and 6 into 2, right? And there is a multiple of 3 also, right? 3 into 4, right? 3 into 4 is also 12. So 4 into 3 I got and 3 into 4. Are there more? The factors are like 1, 6. Sorry, 12, right? 12 is what? 112 is not there. Then 2, 6 is there and 4, 3. I don't think there are. No, it's not me. So we got this answer, right? So the required probability we'll say here. How many of them are there? 4, right? So the probability will be 4 out of 36. That comes out to be 1 over 9. Yeah, 4 into 9 is 36. Yeah, that's done. This is the fourth question out of these 7 questions I have taken. I'll come up with the fifth one. So by the order, it's 1, 2, 3, 4, and 5. Check what does this question says. Same as tossing 2 dice. The sum of the number on each dice is even. So both of them has to be even. Sorry. Both of them is even. So that's what? 2, 2. I'm watching diagonally. You may do it any manner, like you can go column wise. So ignore the odd one. So this is, this is, this is. Ignore the odd one, like I'm ignoring the column of 3. And in the column of 4, 4, 4, these are. Similarly, ignoring the column of 5, I'll get for this. Both has to be even. So I can see counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So the required probability for the first part here is going to be what? If I write PA, the favorable is 9 and the total observation is 36. So this is 1 over 4. Check for the next part. That is sum of the numbers appearing on the dice is 5. Sum of the numbers appearing the dice is 5. Exactly 5 we have to get, not less or more. So I'll look for the one whose sum is 5. I can say start with 1. So 1 plus 1 plus 4 is 5. Then 2 plus 2, sorry, 2 plus 3 or 3 plus 2, right? So 4, 1 I have taken. So I'll go for 1, 4, 3, 2, then 2, 3. And what? 1 is included, 2 is included, 3 is included, 4 is included. The sum appearing on the dice is 5. Yeah, that's correct. So if I take that as PB, there are 4 of them out of 36. So if I reduce, going to be 1 over 9. So this is fifth one. Let's check for the number. This is the next one. So again, tossing 2 coins, what we have to find out? Sum of the numbers appearing in the upper face, the same thing, is 7. So exactly 7 is the sum. So sum as 7. Sum as 7. Where is that? Yeah. So sum as 7. So 1 plus 6 is 7. Then I'll go for 6 plus 1. And then 2 plus what? 2 plus 5 is 7. Then I'll go for 5 plus 2. I can see diagonally. 4 plus 3 and 3 plus 4. So 1, 2, 3, 4, 5, 6. So for the first answer, 6 of them is the favorable out of total 36. So comes out to be 1 by 6. Now let's talk about the next. Sum greater than 11. Greater than 11. So diagonally, look for the sum as 11. Only these two. And greater than 11. So I'll go downward, not above, because these will give smaller number. So you can see that these are the sum which is either 11 or less than 11. So greater than 11 is only 1. So 1 out of 36 observations. So this is the answer for, I don't remember the number question. But anyway, we'll have done this. Now let's move to the properties. Now this we have done. I think we have done 6 of them. This is the 7th. Two different dice are rolled together. Find the probability of getting a number greater than 3 on each dice. On each dice, it should be greater, right? On each dice. So I'll start from below. That's easier because these are big numbers. So they are in each has to be. So greater than 3 on each. Not this sum, right? You have to be careful. They're not asking about this sum. They're simply saying that it has to be, each number on the dice has to be greater than 3. So yeah, there are more. 6, 3 cannot be there. 5, 4 is there. 4, 5 is there. 4, 4 can also be included. Right. I think this much, they are all got exhausted. Because these are numbers surrounding this, I can see. I'll observing like this. As you can see that these are surrounded by 6. These are the numbers having less than 6, less than 3, less than 3, and equal to 3. This is also equal to 3. So how many of them? There are 9 of them. So for the first part, 9 over 36, which is 1 over 6. So what is B? The second part, getting a total 7, 6 or 7 on the number. Let me read it again. Getting a total of 6 or 7 of the numbers on the two dice. Getting a total of 6 or 7 of the numbers on two dice. Total, by that it means to, like, if you are played with dice, when we say that total is that sum here by default. So total of 6 or 7. So total, either we need 6 or 7. So let's check for this one. But I'll go first for 6, and 6 we have already done, right? 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. And 7 is what? 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, and 1, 6. Getting a total. So I'll count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 out of 36. This cannot be reduced. So this is how we'll do. Next, we will do questions based on cards, playing a stack of 52 cards.